Good morning, everyone. Let us start this session. So this is lecture number 14. In the previous session, we started with the non-concurrent, non-parallel force system, so which is also called as a general force system. So this was the first example on the general force system. So here, one beam AB, it is fixed at point A, and two forces are acting on this beam. One is 30 and second is 26 kilonewton. Okay, and one additional couple present in the system, which is 45 kilonewton meter. And the question is, determine the resultant of the system and find its location with respect to point A. So to solve the problem on the general force system or non-concurrent, non-parallel force system, your steps are similar to the concurrent force system. Okay, that is for resultant calculation. So your first step will be to resolve the forces in the system. Then after resolution of all the forces, you should take the summation fx, that is you have to add all x component and take summation f1. Okay. The next step is use the formula for resultant, which is r is equal to square root summation fx square plus summation fy square. Okay. So by using this formula, you will get the magnitude of the result. So once you find out the resultant, then immediately observe the sign of summation fx and summation f1. Okay, and accordingly you should locate the quadrant of the resultant. If both are positive, if summation fx is positive and summation fy is positive, that means your resultant, it will lie in the first quadrant. Okay, so this is the location of the resultant. This is just an example. I have assumed fx and fy both are positive. You have to observe the sign and then you have to decide the quadrant. After that, this is the angle theta with respect to x-axis. Okay. So to get the direction of the resultant, use the formula theta is equal to tan inverse summation fy upon summation fx. Okay. So always remember, when you take the numerator as a summation fy, it means that angle theta, it is with respect to x-axis. Okay. And if you change the numerator, if you write summation fx in the numerator, then angle it is given with respect to y-axis. Okay, so this is the direction of the result. Okay. So after that, you can represent the resultant as r is equal to its magnitude in Newton or kilonewton, and then you have to give the proper direction. So right now, if the direction is in the first quadrant, then you will specify the direction, which is theta is equal to. Okay. So this is the resultant calculation. And after that, to find out the location with respect to given point A, you have to use the Varying theorem. Okay. So this will be your last step, to use the Varying theorem. So from the Varying theorem, its mathematical equation is summation of moment by all the forces about any given point. This is equal to moment by the resultant about the same point. So from this equation, you will get the location, which is called as a distance d. It is the unknown distance of resultant with respect to given point. Okay, so these are the common steps to solve the problems on the general force system. Okay, so let's try to solve the given problem. So just draw the beam AB so that you can show all the forces and you can show the resolution. Okay, so this is the beam AB. Now you can take this point as a point C, then this is point D. So at point C, there is one force. So this is 30 kilonewton. Then at point D, there is a couple. So this is 45 kilonewton meter. Okay. And at point B, so force is 26. Okay. Now for 30 kilonewton, the angle is given with respect to y-axis. So this angle is given as a 30 degree. Okay, but for 26, angle is not given. But you can find out this angle from this dimension. Okay, so this is 12 and this is 5. And this angle is alpha. Okay, so you can use tan inverse to get the value of alpha. So this is tan inverse 12 upon 5. So get this angle. So this is 67.38. So this angle alpha is nothing but angle of 26 with respect to x-axis, okay, or with respect to beam AB. So this is your alpha angle. So you can show this angle. So this is 67.38. So after this, you have to resolve the forces. So that is your first step. So for the resolution of general force system, always remember, resolve the forces at the contact point with the given system or given object. So this 30 kilonewton, its contact point with the beam AB, it is the point C. Okay. So show both the component X and Y at the point C only. So I will draw the first component like this. So this is the X component for the 30 kilonewton. And this is the Y component. Okay. So here X component, its value will be as it is opposite to the given angle 30 degree. So this is sine component. Okay. So this component will be 30 sine angle is 30 degree. And this vertical component, so it is adjacent to angle 30 degree. So this component will be cos. So this is equal to 30 cos 30 degree. Okay, so these are the X and Y component for 30 kilonewton. So this is a Fy and this is Fx. Similarly, resolve the 26 kilonewton. Okay, so for 26, this is the X component and this is the Y component. Okay, now X component is adjacent to this angle 67. So this will be cos component. So here Fx is equal to 26 cos 67.38. And the Y component, it is opposite component. So this is equal to 26 sine 67.38. Okay. So this is the resolution. Now the 45 kilonewton meter, this is the moment. Okay, so we have to keep it as it is. Now next is we have to write summation fx and summation fy. So write summation fx. So for summation fx, this is x component 30 sine 30 and direction is negative x direction. Okay, so this is minus 30 sine 30. Next force is 26 cos 67.38 and it is positive. So plus 26 cos 67.38. Okay, so only two component in the x direction and this is equal to, so take the addition of these two forces and get the value of summation fx. Next write summation fy. So for summation fy, 30 cos 30 and its direction is downward direction. Okay, so this is minus 30 cos 30. Second component is 26 sine 67.38. Again, it is downward, so it is negative. So minus 26 sine 67.38. Okay, so get this value. So your summation fx is minus 5 and unit is kilonewton. So this is the unit given. Okay, and your summation fy is minus 50. So exact answer. So this is minus 49.98. Okay. So if you consider the next digit for this angle 67.38, then I think you will get the minus 50 kilonewton. Okay, so summation fx is nothing but the x component of resultant. So this is equal to minus 5 kilonewton. Okay, so what is meaning of minus 5 kilonewton? The magnitude is 5 kilonewton of the force and direction is towards negative x direction. Then summation fy, which is nothing but y component of resultant and its magnitude is minus 50 kilonewton. So that is equal to 50 kilonewton and this is y component. Okay, that means it is towards negative y direction. Okay, so why these two directions are important? So from these two directions, we can decide the quadrant of the result, whether it is first, second, third, or fourth quadrant. Okay, so what is the quadrant? In which quadrant we will get the resultant? So you can give your answer in the chat box. Quadrant of the resultant. So quadrant is third quadrant because x is negative and y is negative. So draw the quadrant. So this is your Rx or summation fx. This is Ry or summation Fy. So this is your resultant. This angle is theta. Okay. So theta is angle of resultant with respect to x-axis. And now find out the resultant magnitude. R is equal to, in the square root, summation fx square plus summation fy square. Okay, so put this value summation fx and summation fy. So this is equal to 5 or minus 5 square plus minus 50 square. So this is equal to, it is 50.24 or 25 kilonewton. Okay, so have you got the same answer for resultant 50.25 kilonewton? Okay, so once you calculate the resultant, next step is find out the angle theta. So resultant, its magnitude is 50.25 kilonewton. Okay. Now the direction, that is angle theta, this is equal to tan inverse summation fy upon summation fx. Okay. So whenever you use this formula summation fy upon summation fx, so enter the positive values only. Okay. So tan inverse summation fy is minus, sorry, 50 and summation fx is 5. So you will get the answer. It is 84.28. Okay. So in the rectangular coordinate system, this is the resultant. This angle theta, this is equal to 84.29 degree. Okay. So you represent the resultant as R is equal to 50.25 kilonewton and its angle is specified like this. This is negative x-axis and this is the resultant and this is angle theta. Okay, so you can give the value theta is equal to 84.29 degree. This is the representation of the result. Okay, so this is the first part of the question, that is find out the resultant. Okay, so find out the resultant means we have to find out its magnitude and its direction theta. Next is we have to locate the resultant with respect to point A. So read this statement, determine the resultant and location from point A. So just refer this original diagram. So with respect to point A, we have to find out the distance of resultant. Okay, so for that we will use the Variance theorem. So to find the distance of the resultant with respect to point A, use the Variance theorem. Okay, so for the Variance theorem, you will refer the original diagram and the new diagram, which is the resultant diagram. Okay, so I will draw the resultant on the given beam A. So here in the original diagram, we have resolved the forces 30 and 26. So just I will draw the component. Okay, so this is the X component and this is Y component of the 430 kilonewton. So this value is a 30 cos 30 and this is 30 sin 30. Okay, so you can refer the original diagram, no need to draw it again. Then this value is 26 sin 67.38 and this is 26 cos 67.38. Okay, then there is one additional couple present in the system. Okay, so this value for the couple is 45 kilonewton meter. So this is the system of forces. Okay, and we will convert this system of forces into the resultant system. So for the resultant system, we don't know the exact location of the resultant with respect to point A, but we know the direction. Resultant is directed in the third quadrant. So just I will draw the resultant like this. Okay, so this is the resultant. So I have shown this direction because I know this angle, which is theta. Okay, so this is 84. And now we will specify the distance of the resultant with respect to point A. So in the Variance theorem, for the resultant, we always assume the perpendicular distance. Okay, so from point A, just draw one perpendicular on this resultant line or line of action of the resultant. Okay, so this distance d, it will be perpendicular distance with respect to point A. So now this system, that is a system of forces, is equivalent to the new system, which is the resultant system. Okay, the meaning of equivalence is both the system will have the same effect. Okay, just we are replacing all the forces by a single force. Now to find out the distance d, we will use the Variance theorem. So summation of moment by all the forces about the point A is equal to moment by the resultant about the same point A. So just refer the left hand side, which is the summation of moment. So for the left hand side, we have to refer this diagram, that is the system of forces. Okay, so we will start from the first force, which is a 30 kilonewton. Now 30 kilonewton, it has a two component. One component, which is a vertical component, and this is the x component. Okay. So for the summation of moment, we have to take the moment by each component. Okay. So x component, y component, again x component and y component. So select this component, that is a vertical component, okay, which is a y component. So y component, its magnitude is 30 cos 30. And for the moment, always observe the perpendicular distance. Okay, the meaning of perpendicular distance is from point A, if you draw one line up to this point, which is the point C, then that line must be perpendicular to the line of action of the force. So this is called as the perpendicular distance. So this perpendicular distance is given directly 2 meters. Okay. So moment will be 30 cos 30 into distance is 2 meters. Now what is the sense of rotation by this force, which is the y component? The sense of rotation will be this component will try to rotate the beam AB in the clockwise direction. Okay. And therefore this moment will be minus. Okay. So now consider the second force, that is the y component of second force. Okay. So this component is 26 sine 67.38. Okay. And what is the perpendicular distance? So from point A up to point B, this total distance is perpendicular distance. Okay. For the force F1. So that distance is, this is 2 plus 2 plus 2. So there is 6 meters. And again, the moment by this component, it is a clockwise. Okay. So it will try to rotate the beam AB in the clockwise direction. So this is negative. Okay. So these are the moment due to y component of the forces. Now consider the x component. Okay. So here, so I will erase the y component. So just observe this point A. So it is at distance 0.3 meter from this. That is the point of contact of the force. Okay. So these two components, so this is the first component. So you can see there is a distance of 0.3 meter with respect to this point. So which is given here 0.3 meter. So for the first component, which is a 30 sine 30, there is a distance of 0.3 meter with respect to point A. Okay. So that moment, which is a 30 sine 30 into perpendicular distance is 0.3 meter, and this moment it will be anti-clockwise. Okay. So therefore it is positive. Then second is 26 cos 30 67.38, this component. So component is 26 cos 67.38, and the distance is again 0.3. Okay. But this moment, it is a clockwise about the point, and therefore it is negative. Okay. So this is your complete left hand side. So just I will enlarge this image so that you will understand how to take the moment by this distance 0.3 meter. Okay, so this is the point A. Okay, and from this line, actually this is the center line. The point A is exactly at the center of this side. Okay, or the width. So this is 0.3 meter, this distance. So somewhere here we have the point C, and this is the point B. Okay, so at the point C, just I will show the x component. So this is the x component. Okay, and its magnitude is 30 sine 30. Okay, and at this point we have the x component of 26, which is 26 cos 67.38. Okay, now for the first component, which is the fx 30 sine 30, we should take the moment about A. So that moment will be, this is the force, which is 30 sine 30 into, for the moment we need force and perpendicular distance. So perpendicular distance will be, if you extend the line of action. Okay, because force is a transmissible vector, so we can extend the line of action. So this is the perpendicular distance. Okay, for this component 30 sine 30. So this distance is nothing but 0.3. So this is 0.3 meter. And how to decide whether it is clockwise or anti-clockwise? Just imagine the point A is fixed, or you are holding the point A in your hand and you are trying to apply the force at the point C. Okay, so this force will try to rotate the complete beam AB in this direction. Okay, so that is the anti-clockwise, and therefore it is positive. Again, second moment, which is 26 cos 67.38. This is the force into its perpendicular distance. Okay, so for the perpendicular distance with respect to point A, again you can extend this line of action. Okay, no need to draw this line, you have to just imagine, so that you can directly write down the perpendicular distance. So if you extend this line of action and if you draw the perpendicular, so this is the perpendicular distance, that is nothing but 0.3 meter. And how to decide the sense of rotation? So if you apply the force at the point B, okay, then complete rod AB will rotate in this direction. Okay, so we have to imagine this sense of rotation. So this is the clockwise direction, and therefore this moment is negative. Okay, okay, so this is how you can write the moment equation in the Varanas theorem. Okay, so this is your complete left hand side. Okay, so just find out this value, and after that write the moment by resultant about A. So I will write here right hand side, moment by resultant about the A. So this equation will be, resultant force is R, and what is the perpendicular distance? That is a D, and the sense of rotation will be, this resultant will try to rotate this rod AB in the clockwise direction. So this is negative. Okay, and then you will equate this equation with this answer. So just tell me this answer, which is a summation of moment by all the forces about A.